All right. All right, so let's take a look at B. B says, what is the probability that a randomly chosen student is taller than 74 inches? You need to draw a new picture. Do not put on the same picture, please. If you already did it for this problem, it's fine, but just going forward, new picture, please. New picture on B. So on B, I'm going to come over here. I'm going to redraw. I'm going to put my mean, 68. I'm going to say I want to know a student is taller than 74 inches. So here's 74. And I want to know taller. So over here. Shade in the area. Shade in. And then here's what goes in the calculator. We're going to go normal. That tells us it's a normal model. CDF, that means add up. Cumulative, it stands for cumulative. That means add up everything after this. You tell it, okay, smallest number is 74. Biggest number is infinity. So I'll go 1E99 or 9E99. Just any huge number. What is the mean? 68. Standard deviation 3. Let's go ahead and plug that in. Go ahead and plug that in. Verify that you're getting this. Please verify you get this. Please verify.
Does it matter the order that we recommend?
Yes, order matters. Order does matter.
So why did you put the other one? I mean, the positive infinity second.
Because that's the biggest number. So it goes small number, comma big number, comma median, comma standard deviation. What's up, Norma? Keep getting error, okay.
5, 2.
Oh, you're doing integral? Okay, so here, so you put it lower bound here, 74. So you can put 1.
Oh, this okay.
All right, so everybody got this? 0.02275? Cool. All right, let's look at C. It's right up on the board. So those who are good can move on their own to to letter C. Let's look at C now. What is the probability that a randomly chosen student is between 60 and 72? So again, I'm going to draw my picture. Up, down. This is going to be 68. And please, again, just make sure you're writing what you're plugging in. So here's where we're going to plug in. And please verify that you're getting All right, so let's take some questions on this. So basically what we're finding is the likelihood that some data is in here. So maybe what we'll do in the next few days is I'll bring in some data from some old unit tests and we can see where people are. So what percentage of the people score between a blank and a blank? Chun-Li.
Do you still want us to round to the third?
Yeah, I think 3 will be good. I think 3 is good. 3 decimals.
905.
Yeah, so 0.905. And if somebody says, explain what you found, what you said is, the probability somebody's height is between 60 inches and 72 inches is 0.905. In other words, there's a 90% chance somebody is between 60 and 72. Questions? Okay. Let's push forward here. So I'm going to talk all of today, and then you'll have all of tomorrow without me saying a word. So let's keep going. No, keep going, keep going. All right. So now we have another method for solving problems like these, a different method. And sometimes on the free response, they'll say, show your work using both methods. So this method is called using what they call a z-score. A z-score. This is for the second model problem, right? No, the one about the SAT. So I skipped that other one. This is notes. This is notes. This is notes. Yeah, you don't need it. This is notes on just another technique. There's a different technique. We'll call it the z-score. And the z-score tells us this. It says if I tell you the mean, and I tell you a score, and I tell you the standard deviation, I tell you the mean, I tell you a number, like a score, and I tell you the standard deviation, you can tell me how many standard deviations away the number is from the mean. Let me explain what that means. The z-score tells us the number of standard deviations a value is from the mean. And it is just another way, it's another tool maybe you want to call it, another tool to solve for the percent probability, or for the probability. You don't even need percent. Probability. And the formula for z-score, and again this will make sense after I do an example, the formula for z-score is the z-score equals whatever x value you have minus the mean divided by the standard deviation. X value minus the mean divided by the standard deviation. And again, this will all make sense with an example, so just bear with me here for a few minutes. Now, if you guys recall, on the common assessment, you had those big tables at the end of the exam, and people may have been like, why do we have these tables? Tables are going to reflect the z-score. So in the good old days before the calculator, you had to use the tables to find the probability. You had to do it manually. There used to be tables that were like log values. You know how you can plug in the calculator, like log of 25, you get the answer? They used to have calculators. My dad said he was an engineer, and have tables, log tables. It's like big books you have to see. Log of 25. Okay, what is it? Anyways, what is a z-score? And let's see what we mean by z-score. So, yeah. Okay, so the x is just a number. So like in this case, it would be like 72 or 60, whatever. Yeah. Right. So let's look at the model problem here. Let's look at the model problem. And let me work through the model problem. It'll become very clear why we have this. So the model problem says many students take SAT and ACT for college, as you all know. College Board reports that the average SAT score, so the average SAT is a 1,000. Reading and math only, with a standard deviation of 175. So standard deviation of SAT is 175. For the ACT, so the average for the ACT is 21. Right. Standard deviation on the ACT, right, is on the problem, is 5. Is 5. All right, and their question is, say you scored an 1170 on the SAT and a 27 on the ACT. So I made an 1170 and I made a 27. I did better than the average on both tests. I beat the average here, I beat the average here. The question is, on which exam did I do better compared to everybody else in the country? So compared to the average, which one did I do better? That's what we need to see. And here's how the Z-score is helpful. If I asked this question to somebody who was not in this class, they would say, oh, I did better on the SAT. I'm 170 points above the average. Here I'm only 6 points above the average. This is better. That's what a lot of people will say. But that's not the case. And let's find out why. So, if I calculate the Z-score for this right here, I would say the Z-score equals X, which is what they give me, so 1170, minus mu, 1,000, divided by 175. And I would get 0.971. So what this is saying is, my score of an 1170 is 0.971 standard deviations away from the mean. So what does that look like on a graph? Looks like the following. Here's the SAT graph. The mean is right here at 1,000. And my score is here at an 1170. So here I am, 1170. So I'm right here. So I'm above the mean, but not one standard deviation above the mean, because that would be 1175. So I'm a little bit less than one standard deviation above the mean. I'm 0.971 standard deviations above the mean. Are there questions on what that means? Please stop me. You have to stop me, guys. Yeah. Sure. Yeah. So if my score was an 1175, if my score was an 1175, I'd have 1175 minus 1,000, which is 175, divided by 175, and I'd get 1. Because I would be one standard deviation away. But my score is little less than that. I'm only at 1170, so I'm little less than one standard deviation away. I'm 0.9 standard deviations away. Does that make sense? Now let's see about the ACT. So ACT, the Z-score, is I earned a 27, the average is a 21, and the standard deviation is a 5. And that gives me a 1.2. So that means my ACT score was 1.2 standard deviations above the mean. So which exam did I do better on? The ACT, because compared with everybody else, I'm higher here than I am here. Here I'm more than one standard deviation away, 1.2. Here I'm only 0.971. So if you think about the graph for ACT, here's the graph. Here's the mean at 21. Here's one standard deviation away at 26. And my score was over here at 27. So I am above one standard deviation. Here I'm below one standard deviation. This is where I did better relative to other people. So definitely for the previous problem that I did. On this one, I think it's helpful. I don't know the answer to that question. I can ask the other teacher who's actually graded these exams, like at the AP, so I'll ask her. It's good. It's a good question.
So when you're calculating the Z-score, it's better to have the highest standard deviation to show that you're above the average?
Right.
Just in this scenario?
No. You always want to be way over here on the right. But it would be worse if you were way over here on the left. Like you could have a negative Z-score, which means you're below the mean. So like imagine you made a 900 here. 900 minus 1,000 is negative 100. That's going to be a negative number. That's going to be way over here. Your Z-score will be negative. Your standard deviation's below the mean. That's bad. I mean, bad. You don't want it, right? Okay, so let's look at part B. And again, if you're already good with this, you can try to push ahead to B and C. I'll go ahead and model it here, though. All right. So part B. Texas A&M automatically admits all students who get a 1300 on the SAT or a 30 on the ACT. On which exam is it easier to meet this requirement? Let's find out. Again, if you can try to do this on your own, go for it. I'll model up here for those who need to see that. If you just think intuitively, you want the test where the z-score is lower because you want the easier test, which means where you have to be less above the mean because you want it to be easier to get in. So let's see which one it is. Go ahead and check your answers again. If you're good, try C. That's a little bit more complicated. But if you have questions, here's B. So I'd love to take some questions on B. And again, if you're good, you can go ahead to C. And then you have a couple more questions about the AP Stats classes. Let's me stop here on B. So any questions on B? All right, I'm going to push forward now to C. And again, if you feel like you can do C on your own, go for it. And just sort of check up here. If you received a 1200 on the SAT, what is the equivalent score on the ACT according to the averages? Equivalent score on the ACT according to the averages. Ooh. Well, let's find out. And here's the way I'm going to do it. And again, I'm going to try to avoid speaking too much right now because I want to give those people who are trying it an opportunity on their own. Here's what I know has to be true. So those folks who are with me, are there any questions why we need this to be true? Again, please stop me if you're unsure why this has to be true. Okay. So I'm going to work with this side first. So here's the equation I've got set up. Here's the equation I've got set up. Shun-Li, we all right? You already solved this? Good. Go to the next problem then. There are plenty more to do. All right, so let's see. Let me work through this. So I've got this situation going on here. This is a number on my calculator. This side is a number. All right. Let me go to my notebook here. And once I multiply both sides by the 5, bring that over here, I get this. So I'm going to add this over here. Some of you may be doing the algebra differently, that's fine. But the final answer is the following. Really? Which one? This? This? Did I not multiply by 5?
No.
Very possible. This score does seem a little bit low.
It's supposed to be 26%.
It is. Very good. Very good. Very good. That's why I have you all here. So this is divided by 5. So multiply both sides by 5. Very good. Let me bring it over here. Is this looking better?
Yes.
Okay. So maybe this is what people got? 26.714?
Yes.
Yeah, so you can write this, and then I think in a sentence you could nicely say you would need to get a score of about a 27 on the ACT, because certainly you're not getting a portion of a score. So questions on this? So now, one final point before you guys get released. One final point, and there's not much release time, but you have all of tomorrow. The final point I want to make is the following. Let me make one final point. So let me get folks back up here. Real quick. The one final point we have is the following. The way, so there's just like one question left, which is how do I use the z-score to do the probability questions I did at the beginning of the class? This is the last piece we have to do. And the way we do it is the following. So if we go back to the model problem 1A, it said the height of the mean is 68, standard deviation is 3. And they wanted to know what is the probability that somebody is shorter than 65. So what you can do is the following. You can calculate the z-score, which will be 65 minus 68 over 3. I wanted to know 65 minus the mean over the standard deviation. This will be negative 3 over 3, so this will be negative 1. This will be negative 1. So this is saying what? 65 is one standard deviation below the mean. And then you could plug this into your calculator and you will get the same answer. Normal, CDF, and you wanted to know how many people are shorter than this, so negative infinity, comma negative 1, comma 0, comma 1. And what you've done here is you've said, okay, I want to know how many people are shorter than 65, and what I did is I said this. You did the lower bound, you did the z-score, and then you put in 0, which is the mean of what we call the standard normal model, and 1, which is the standard deviation of the standard normal model. This will give you the same answer. I'm not going to belabor the point right now as to why this works. That will come at a later point. But you could do this, and this is what is printed on the calculator sheet. This is how the other campuses do it right away. I don't think this is as intuitive as what I did at the beginning of class. What I did at the beginning of class always works, every time. I think that's a more intuitive way. I just wanted to introduce this now. The reason we call this standard normal is because the mean is at 0. You'll get the same answer that we got in A if you plug this in. You don't have to do it. In fact, I would encourage you not to do it. I would encourage you to do it the way I taught at the beginning of class. I just want to expose it because it might come. It will come up later on. And by later on, I mean a few weeks, 3 weeks. Okay. So other than that, that is all I have. You have, this is due on Thursday. So what you have to turn in on Thursday is page 2 and page 3. So page 2 and page 3 for Thursday. You have all of tomorrow to work on it in class. Have a great day, folks. I'll see you tomorrow.